Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia. Hi, I'm Sharon Todd, a certified professional ergonomist and the current president of the Human Factors and Ergonomics Society of Australia. Today, I'm chatting with Antoine Jdeidani and his part in the design of the C30 Bombardier Train in Sweden. Antoine is the Human Factors Associate Director at Arch Artifex, providing human factors consulting services to transport projects in New South Wales, Victoria and Queensland. Antoine has over 10 years' experience in human factors engineering and human-centred design, including design of consumer products and services and the development and delivery of major transport and infrastructure projects. Thanks for joining me today, Antoine. Maybe would you like to tell me a little bit about yourself? How did you become an HF professional?
Well, in my early days, sort of growing up, I was sort of on two minds. I had sort of a very sort of structured analytical mindset. I love processes. I love sort of understanding how things work and sort of build stuff. And on the other side, I was very creative, love art, poetry. So I was sort of wanting to have something more on the creative side as well. So during my adolescence, sort of tried to find some nice careers where those two sort of merge. And I was leaning on architecture for a while because sort of you had that architecture, like engineering, sort of designing houses, both the creative side as well as sort of the structure behind civil engineering. But then I found a master's degree. So I'm from Sweden, so this is all in Sweden. North of Sweden in Luleå Technical University, University of Technology. There was a course called Ergonomic Design and Production Engineering, and I think it's called Technical Design now. But it sort of piqued my interest in terms of, you have the engineering side, you have the sort of product development and sort of building stuff and designing things. But you also brought into like the third aspect of people and being sort of more mindful and intentional with the design and the projects that you're sort of undertaking. And that spoke to me very much in terms of working with people. So I didn't sort of fully understand how much I enjoy working with people until I started that master's degree. I had an inkling since I'm a middle child and people tell me I'm a great mediator. And so I always sort of try to help my family members sort of get to a common ground. And you have to sort of be that type of person to when you're working in human factors, because you're working with a lot of different people, a lot of different disciplines that often can't really communicate with each other. Everyone is sort of focused on their main task. And, the human factors engineering and it just spoke to me in terms of like being that cog in the wheel of bringing everything together and sort of like melding it and making sure everyone sort of understood the intention behind everyone's work. Like, what are we striving for? What are we sort of building towards? And yeah, this is sort of an extra layer of sort of perspective in that career choice. So yeah, and throughout my career, it just sort of cemented that I've made the right choice. It's just it's been a very fulfilling and it's still fulfilling and an interesting job.
So your career has evolved, has it not?
Oh, yeah, for sure. It's just started like with everything, like in universities, you do tend to, get into all of the methodologies, the structure, you sort of go through step-by-step procedures and, try those out in different settings. I was lucky that the University of Technology in Luleå had a lot of great collaborations with local companies. So we were actually out doing projects and being a practitioner very early on. So we worked with like local gyms, we worked with local sort of industries and factories, looking at working environments, designing sort of different areas for people. Also sort of like the base of that education was mechanical engineering as well. So we did a lot of sort of automotive and work with engines as well, and the maintenance of engines. So it was definitely a lot of interesting projects throughout that education phase. But when you also get into the field and get into your career, you start very wide. Often you have like a breadth of knowledge in very many different areas, and then you sort of hone in on key things that you need to do in your day-to-day work, and you sort of get to that detail and start to sort of become more and more of a specialist when you sort of as you go. And that's also been very interesting, and sort of like deep diving into different areas, and sort of like for each project, like you're never fully, like, I can't say that I'm an expert in everything. I'm an all-rounder, jack of all trades. But when you are in a project, you do tend to, lean in on all of those research material that support, that informs the context of the use cases, the end users, that whole, all of the assets and products and systems that you're helping develop. So you become sort of very invested in that, and having that lens in the workplace also sort of very fulfilling. And also, of course, seeing the fruits of your labor at the final end of having something being built and being used, which is the asset that the product that we're going to talk about today is Stockholm's metro train that's been now in operations for the last year and a half, 2 years. And that's been like 7 years in the making. And now having it out in operations and hearing the feedback of how people view the train and what they like about it, both the customers as well as the staff, is a real joy for me to see.
So that's a lovely segue, because I was going to ask you actually where you're working. So we're working in rail. What was your role as an HF professional in the design of this train?
Back then in 2014, I was working sort of odd jobs in product design. I was doing a lot of different sort of customer products. So this was a very sort of first like big project. So when you're working in a design bureau, you sort of tend to do like small projects, very sort of quick, iterative, which is also very fulfilling in terms of creativity. You are able to sort of really sort of work those creative muscles. But coming into rail and transport, you're sort of brought into projects that are spanning, years. That is sort of a lot of research and work has sort of gone into setting those up. There's a lot of cost involved, a lot of investment to build all of that. So there was that sort of sense of, now I'm like, it's a real, important project, and you have to sort of make sure that you get on the right foot of that. Also, the complexity level is through the roof. Looking at all the different systems of the train, it's, you have the drivers, you have like just the cab itself being such a tight-knit area within the train. You have so many systems vying for place, and working with the designers to make sure everything is accessible as well as usable for all the driver instructor, the cleaners, the maintainers, both physical assets as well as the application of it, like the logic behind all the button placements and making sure that those are correct. It's like the complexity is definitely much higher. But I enjoyed that. That's sort of what drew me into it. So I was working with Bombardier for that project, and I just applied like anyone else for the job. I was lucky enough to get it and be involved in that project.
So you started to talk about this Bombardier train. I believe it's a C30 train. So, and you've talked about designing for at least the driver. So let's maybe just talk about who else are you designing for? Who are the target groups?
Sure. I can sort of give you an overview of the train itself. So one of the key factors so this train was for Stockholm Länstrafik, which is the Stockholm public transport government agency. They wanted to, most of their C20 metro trains are sort of nearing the end of their life. They want to have a modernization, refreshed fleet. So they're looking to invest on new rolling stock, which is trains. The good thing about sort of how they approached what they were wanting from a supplier, they set the expectations very early on that they want to have a project that's very focused on users, looking at all of the different users of the train and make sure that there's that user-centered design throughout the whole of the project, like setting the culture from the get-go in terms of customer focus as well as staff and drivers. All of the users needs to be accounted for and considered throughout the design. And Bombardier sort of was very for that, which is probably why they won the project. I came in just at the end of reference design where they had sort of the conceptual model of the train, and was sort of working from then on all the way through to the final detailed design. So the train was basically sort of, if we cut it up into different chunks, you have the passenger cab, which is, the front end where customers sort of interact. There's a lot of systems within that. You have, the passenger counter on the doors where, it counts how many passengers go in and out. So it gives you a loading in terms of how crowded that particular cab is. You have to sort of consider accessibility to different types of passengers, people with mobility disabilities, visual impairments, groups for, families with prams. Also, in terms of sporadic travelers and frequent travelers, like you need to sort of look at from everyone's perspective and to accommodate them, to give them that sort of environment, a comfortable ride for the passenger cab. The driver cab, it was all about, the driver instructor, but looking as well at the maintenance of that, since it's a very sort of confined area. So all of the maintainers' tasks will need to be very sort of thought out in terms of how they reach all of the nooks and crannies and make sure that they can maintain it. And as well as throughout the whole train, cleaning was also a big factor of making sure that it's very easy to clean. There's a lot of thought in terms of the man hours it takes to clean a train as well. Like you want to have a lot of efficiencies as well in terms of those maintenance tasks and cleaning tasks. Often in transport and rail, we talk about human factors being linked to safety and risks. And we definitely sort of input into that realm where we try to reduce the potential for human error and make something more safe, more reliable. But there's also that human performance element where we are trying to make something really easy to use. So it's a natural sort of application of an asset. It doesn't feel like it's a disjointed system. So when you're at work, you're doing your tasks, you're not constantly thinking that like have to sort of be brought out of your natural sort of flow of work and saying like, oh, why didn't this do what I thought it would do when I wanted it like that? It's like those moments, tend to sort of get you out of the flow of your work, and can, when you have when a user experience a lot of those disjointed systems, can have a combining effect that can create risks within live operations. So when government agencies, when the decision makers look at a system in isolation, they might think, oh, that's acceptable. It's just a minor nuisance. So we can accept that. Let's move forward. But if you look at it as a whole, those little things impact the greater operational sort of performance. So we do tend to focus on that aspect as well throughout the work. One last piece is the undercarriage. Of course, there's a lot of mechanics that goes underneath the train, of course, and that's also a lot of maintenance aspects. And when designing a train, you're not just designing the train; you're also looking at the environment where the train will be maintained. So, Bombardier was a supplier of the train, but then there was another supplier of the depot that the trains will be maintained. And so there's a lot of interfaces and interactions between the two as well to get it right.
So you've mentioned obviously the need for natural flow, and things need to feel natural. And I immediately think of the driver at that point. So let's maybe focus on the driver's cab for the moment. What are some of the HF challenges for you designing for the driver?
So in terms of the driver's cab, we were lucky enough in the project as well. This is one of the requirements that was set out by Stockholm Länstrafik, is that they wanted to have a workable, a mock-up model. So we built a mock-up model. We started with just regular sort of cardboards that went to like wooden features. And then at the end of it, you had sort of a very stylized, like this is how it will look coming out of the production hall type model. So we had those iterative mock-ups that we could bring in user groups and really sort of get stuck into workshopping all the different areas of the design. But if we take it back, the really sort of first take is to basically do a lot of observations of drivers in their current environment, in the current train, trying to identify basically, the pains they gains in terms of that, the current design, what they like, what is can be better. We also did a button frequency analysis where we basically recorded how often they pressed a specific button in terms of functionality. A lot of that data gathering helps to really sort of understand all of the tasks for the driver, as well as the driver instructor during operations, and inform the priorities of those functions. Because when you're designing a new cab, you want to make sure that stuff that they are accessing regularly, like every minute, every half a minute, you want those functions, those buttons to be very clearly sort of visible and close, so they don't have to sort of have to extend to reach them every couple of seconds. So that was definitely something that we did to understand and sort of inform those design decisions.
So what other tools did you use? This is really interesting, especially the looking at the button analysis and the frequency. You talked about observations. What other tools did you use or do you use when you're designing for drivers specifically? So
we had also eye tracking as well in some cases. So the idea with the eye tracking, and this is, of course, you would get permission for the drivers. Some of them decided not to do it because they didn't want to drive with that equipment on, but some were comfortable doing that, and that sort of also showed sort of where their focus and where they're sort of looking at as well. That data helps look at sort of the position of screens and type of information to make sure that it's similar to like a normal car. You have an HMI, like a human machine interface display, which gives you a lot of information in terms of your speed, different types of alerts or faults within the train itself. So if something is wrong with the train, some system has failed, that will pop up an alert. So there's a lot of that type of information being displayed, and knowing sort of where to place that information so it's less intrusive to the driver, understanding sort of what is relevant to show and what is not relevant is a lot of it is also very important. So a lot of analysis were done to look at basically their field of view, or how they sort of as they drive, how their sort of field of view changed throughout the trip, and where is like the sweet spot of placing the information so it's always visible, always sort of accessible to them. And then basically listing through all of those different types of alerts and going through workshops with the driver. So we had a user group of 7 drivers, which were sort of always involved in the project. We could bring them in for workshops. I think we did this is just one user group out of 20. I think we did like 25 workshops throughout like a 2-year. So we had a great working relationship with the drivers union, with the drivers group, and we're able to really bring them along the journey of, designing something for them. And you can feel sort of the sense of ownership as well at the end of it, as sort of like them being involved and representing their user group. And they got that sense of, pride and ownership of the design, since they've been sort of involved in shaping it throughout the journey.
Did you use that same level of collaboration for cleaners, maintenance crew, security?
Yes. So maintainers, we also had a group of maintainers. Now, maintainers were a little bit trickier, since, you have specialists maintainers in different areas. So you would have maintainers that are focused on, the door mechanics. You have other maintainers that sort of look at the engine and the traction power. So we were able to get 1 or 2 from the different user groups, and we also had an underframe mock-up as well. So we basically built very rudimentary boxes. We didn't get that to the same fidelity as the actual train, the top level of the train, like the passenger cab and the driver's cab were at the end of the project very detailed in terms of like the fidelity of what it will look like as a finished product. But the other frame sort of stayed in terms of rudimentary boxes, but we integrated sort of like the different covers where, so say, for example, you have a box in between a wheel set, will be at a specific level within a maintenance hall, and you need to sort of get the cover of the box out. So we looked at the weight of that, the posture of, getting to that, accessing that cover, moving it off. Looked at different designs of how we could, reduce that manual handling, making sure that they have access through all the different nooks and crannies of the underframe. So that was very interesting as well. So a lot of workshops went into, play around with that mock-up and look at their tasks as well. The mock-up was also used for looking at the time it took to do some of the maintenance as well. So for the cleaners specifically, we actually cleaned the whole mock-up like they would clean a normal train, and sort of timed that as well. There's a lot of disciplines within the project, and one of them being the RAM engineers, who looks at reliability, availability, and maintainability. That's what RAM stands for. And they look at the entire system, the maintenance processes for the entire system, train for the whole of the life cycle, looking at all of those the time it takes to do a maintenance, how frequent do you need to do the maintenance task, to visually inspect something or to change it out, to make sure that you have that availability, that the train doesn't break down in the middle of operation. You sort of tend to keep that quality up. So we looked at most of the frequently done tasks, maintenance tasks, and one of them being cleaning, and looked at sort of the time it takes to do the cleaning and the amount of man hours and the workforce size needed to do that. Human factors really sort of influenced the ease of use, ease of cleaning the train, and it was very focused on. When you look at human performance as well, you automatically get cost savings throughout that whole process. One example I like to give is there was one maintenance part. This was in the passenger cab, right around the door frame, where to inspect something they needed to. It took like 10 minutes to get around another component. So they had to remove another component to inspect one component that's sort of behind them. And they do that sort of in every month. So you say 10 minutes is not a lot, but if you look at the average lifespan of the train, which is 30 years, and then you add all of those minutes up to do those tasks, it becomes a lot of a big cost for the operator in terms of maintaining that asset. We were able to change the design and bring that a little bit forward, so you don't have to sort of disassemble, and that went from 10 minutes to like 5 seconds. And you could directly see there, like we've saved hours of work for the entire life of the product, and that's several $1,000s saved for the operator. So it's those type of efficiencies that, when you are fully integrated into design, you can pick up and inform the different disciplines leads. Like, look, we can do this better, and we can save a lot of time and effort to do this task if it's done frequently.
So this requires an enormous amount of observation and hierarchical task analysis, I imagine?
Oh, yeah, for sure. The task analysis was sort of the foundational of any real sort of understanding of context. We had a great team that looked at system integrators. In Sweden, they were called the functional engineers. So they looked at the entire function of the train. But basically, it's system engineering, where they break down all of the systems, all of the interfaces and tasks. And that gave a really good sort of blueprint of the entire train. And then it was up to me to sort of note down all of the human to human, human to system interfaces within that system, and then look at those tasks individually. So a task analysis was sort of underlying the entire sort of work. Early on, when you build that task analysis, you can directly start to capture design requirements for each task. You look at the task in terms of frequency, in terms of the level of importance, how those tasks interact with another task, and you start to sort of build that picture, and that informs where you're placing the key design requirements, or human factors user requirements. You can call them HF requirements, ergonomic requirements. It's all the same in terms of making sure that the design is meeting user needs for those specific tasks. So we used the task analysis in the beginning as a prompt to collate all of those requirements, and then had that throughout to look at the potential for human errors throughout those task analysis, looked at specific workload for key end users that had a lot of task switching and a lot of critical tasks, like the driver, for example, had a lot of critical tasks that they need to do, like So in Sweden, they don't have a guard and a driver. So the train was designed to be semi-automatic. So it drove itself. So the driver basically is monitoring the train driving itself, and they primarily operated the doors, since the infrastructure, like the platforms in Stockholm, doesn't have it's not a closed system where they have platform screen doors. So the driver is always there to be able to take control at the moment's notice and manage the doors to make sure that no one gets stuck or injured. But essentially, they're pressing a button, and then the train drives itself to the next station and brakes itself, and it stops itself on the correct platform, and then they basically manage the doors. A lot of those type of tasks where how they're monitoring, making sure that they fully aware of what's going on in the system, understand what the system is doing when they are not in control, was very important for the driver. So very transparent in type of communication and information that is presented. That was like the most cognitive heavy sort of area that we looked at.
Had the trains prior to the C30 been semi-automatic as well?
I think some of them were, and I don't think it was the full fleet, but yes, there were. Some of them were managed completely, had the system already. Not sure exactly which supplier had that, integrated that system, but yes, they were already sort of managing that.
How did you manage drivers who may have felt uncomfortable with that? And I'm assuming that at some point the driver may need to take control of the train again.
So the driver would operate the train sort of from the depot out to the starting line for the train to sort of kick off into semi-automatic. Some drivers also, it was a choice whether to use the semi-automatic or not. So some drivers preferred to drive manually. So there was different modes that you can set the train on. So you could set it for fully manual and drive it manually if you like. So we had to sort of account for different modes. So if you have sort of full manual, the display would be a little bit different in terms of what is presenting you. Semi-automatic, it's a different type of UI as well, user interface. And the trains were prepped to be fully automatic as well. So the whole train is very modular and flexible. So I assume in the future, when the Stockholm Metro stations have built platform screen doors and sort of isolated the entire sort of people from the track, from the rail, that they can just completely take out the driver's cabin, just create additional seating and have that completely open to the front and back. So in the future, these trains are sort of prepped to be fully automated, unmanned trains.
In part 2, Antoine will discuss more about the driver cab design, the role of the human factors professionals, and the key human factors challenges and lessons that he's learned from this design project. Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.